Hello, everyone. I'd like to welcome you all to today's webinar, which is about the workflow between Plant 3D and Inventor. Thank you for registering, and it's a pleasure to have you all here. In today's webinar, we'll show you Plant 3D and Inventor products, mainly focusing on the workflow between these two products. We'll make sure to highlight the best practices, do's and don'ts, some tips and techniques, and the correct workflows so that you can work with these products without any hiccups. Here's the agenda for the webinar. I'll start with brief introductions. My name is Junaid, and I'm a technical consultant for Autodesk Plant and Manufacturing Solutions at SolidCAD. With me joining in this webinar as a panelist is my colleague Imran. Imran is a technical consultant for Autodesk Manufacturing Solutions. In only a few minutes, he will get into action and will show you the Inventor side of things in this webinar. My sales colleague Syed Rizvi is also available as a panelist in this webinar, just in case you have any sales-related question. A little bit about SolidCAD. SolidCAD has operated as an Autodesk Platinum partner in Ontario. Today, we are the only Autodesk Platinum partner in Canada. We provide the highest level of service, expert support, and a broad range of custom professional services and product expertise for technology. SolidCAD specializes in technology that supports multiple industries, including architecture, engineering, construction, civil infrastructure, and manufacturing. We employ the largest team of industry technology experts across Canada in all time zones and both official languages. With this, let's start the live demo. Please be informed that you're welcome to ask questions in this webinar. We'll be more than happy to take a look at the questions in the end. Duration of the webinar is 30 minutes, so just in case we run out of time, we will get in touch through emails with all those who ask questions and try our best to provide you with the answers. First, I have a quick poll question for all the attendees. It's coming up on your screens in only a few seconds. You will have about 10 seconds to provide your response. All right, I have received the responses, and it's good to know that majority of the attendees are already using Plant 3D and Inventor. So let's start the demo. So here in my machine, I have an example project loaded in the project manager, where I have some specific directory structure for storing different kind of files. So in the steel structure folder, I have a structures drawing. As you can see, the structure I have in this drawing has been created using the Plant 3D structure module. I have attached this structure drawing as an XREF into my equipment drawing and used it as a reference to place my equipment. The equipment that you're looking at in this drawing has been created using the Plant 3D equipment module. In the next step, I'm going to attach the equipment and structure drawing into the piping drawing because I want to use them as a reference to start placing my piping components and pipe runs and pipe supports. So I'm going to open up the piping drawing, and using the right-click menu option, I'm going to attach the structure drawing as an XREF. That's attached. And I'm going to do the same with the equipment drawing as well. And equipment drawing is also attached. Okay. Now that both of these drawings have been attached as XREFs, I'm going to draw a quick pipe run connecting the vertical tank to the horizontal vessel. So I'm going to start from this nozzle. The size of the nozzle is 6 inches. So I'm going to adjust the the size from the drop-down list, click on the route pipe tool, and I'm going to snap to the node of this nozzle and use the options available to change the compass or change the plane. And I'm going to define the vertical drop of 6 feet, change the plane one more time, and I'm going to define a length. Let's say this is also 6 feet. I also can do a little bit of auto routing, so I'm going to snap to the node of this nozzle on the vessel, and I'm going to accept the second placement. Okay. The pipe is drawn. Next, I'm going to click on this vertical pump and a pipe, and I'm going to use the plus sign grip to connect the pipe to the other pipe, and program automatically inserts the T's. I can click on the T's, and I can use the substitute part grip to substitute the T to the reducing T. And the program automatically inserts the reducers because the pipe size is still 6 inches, which I can change by going to the properties window. So I can change the size from 6 to 4. The size of the pipe is changed, and the reducers are gone. Next, I'm going to go inside the tool palettes, and I'm going to click on a valve. I'm going to search for the globe valve, and I'm going to place that globe valve on this pipe. Snap to the midpoint. Let's define the orientation of the hand wheel, and I'm going to place the same globe valve on this pipe above as well. And you can see that the program automatically adjusts the size of the globe valve according to the size of the pipe. I didn't have to make that adjustment manually. I'm going to end this placement by placing a couple more gate valves. I'm going to place a gate valve here, and I'm going to place another gate valve here. And if I want, I also can assign the tags to all these valves. I'm going to assign a line number to this pipe run. So in the right-click menu option, by using one of the methods for selecting the pipe runs, I'm going to highlight the entire pipe run, go to the properties window, and I'm going to assign a line number. Let's say the line number of this pipe run is 1000. Okay. So the line number is assigned, as you can see in the tooltip that pops up. Well, at this point, I'm going to save my drawing, and I'm going to give the control to my colleague Imran, who's going to show you how you can create an ADSK file of an equipment in Inventor. Once he's done, I'm going to take the presenting role back, and I'm going to then show you how you can import that ADSK file in Plant 3D, convert that into a Plant 3D equipment, and how you can use those nozzles to draw new pipe runs. So over to you, Imran.
All right, thanks, Junaid. All righty, guys. Again, welcome. Welcome to the webinar, and thanks, Junaid, for showing us that. So what I want to show you guys is I want to show you everything to do with inside of Inventor, where we can take a look at how we can simplify a model, and then we'll take a look at level of detail, and then we'll take a look at how we can create that ADSK file for Junaid's drawing here. Now, why do we want to simplify a model, right? So out of the box within Inventor, we have what we call level of detail. So here I've got level of detail. You've probably played around with it, you've probably not played around with it, but it's always been inside Inventor. So what level of detail allows us to do here is it allows us to take a large assembly that we have like this, and it enables us to simplify it. So out of the box, we have master, we've got all components suppressed, we've got all parts compressed, and we have all content center components compressed. So if you're opening up an assembly, even remember that there's an option that you can open it up with a specific level of detail. So here, if I go into options, let's just say I don't want to open up the assembly inside of the master view, which is going to show everything. So for example, in this chiller, if I don't need to show all the the assembly with all the subcomponents and so forth, I can create a lightweight substitute level of detail, and it's going to open it up quicker. Again, the whole thing is, why have everything and anything shown on the screen here? So notice down here, I've got about 1,600 different unique types of files that are open within this model. So, that's essentially with all the different occurrences and so forth within the assemblies. So here I have a lightweight option. If I double click on this lightweight, it's going to go in there and start to suppress certain components. Notice I went to 524. Now this is more of a lightweight model where I can work with inside of Inventor. I can rotate it around. Why have all that detail when you don't need the detail and so forth? I can even take it a little bit further. I've got this fence. I can turn off that fence material and just put like a solid, transparent, like a flex board or something, and have that visible. Why have all this detail when we don't need it? This is where level of detail is helpful, right? Now, a couple of things. If I go back into my master, if you haven't played with level of detail before, again, if I double click on the master, it's going to open up and bring in all my components inside of my assembly again. So a couple of things I just want to show you. So here, let's just say I wanted to suppress like the outer shell. So here, if I right click, I can go ahead and turn off the suppression, right? So here, if I click on suppress, this is where level of detail kicks in. Notice here, there's visibility as well. Visibility just says, hey, I'm just gonna, not show this inside of my view right now, but it doesn't do anything within the computer's memory. Suppression completely removes it out. So here, if I turn off the visibility, notice here, I'm still at 1632, total occurrences, okay? So here, if I go back and just do an undo, bring it back, if I click on this again and I suppress it, notice the number here goes to 522, right? So now we have, a lighter model that we can work around with. Why have all that detail shown when we don't need to work with inside of it? Another core one here is all content center components, right? As an Inventor modeler, you want to put in everything, like nuts, bolts, fasteners, so you can get the accurate weight of how much, your model is going to be. Like if we have to, transfer this chiller, I need to understand how, how my skid's going to weigh and so forth, right? Because that's going to be shipping costs that I want to take into consideration. But if I'm modeling, I don't need to show all that data on, right? So here I can turn on all content center suppress, and it gets rid of it. Now, if you haven't played with level of detail, notice here underneath my chiller assembly, I've got bracket level of detail 1. So anytime that you suppress a component, it's going to turn on the level of detail. So here, if I go ahead and click on save, you're going to get a pop-up that comes up saying that the current level of detail is locked, meaning I can't save this on the master, right? So here, if I go ahead and click OK, it's going to pop up with this dialog box. A lot of people get scared with this dialog box thinking, like, oh, what is this level of detail? I didn't change anything. Why is this coming up? All this is saying that you have a new design representation. How do you want to save this within your model here? So here, if I can say, I can say my level of detail, okay? And I'll go ahead and click on yes. And here it's just going to save the assembly. And here what we're going to see is my level of detail here. So if I go back into master, it's going to load all the components again. So it's going to take that outside enclosure and it's going to bring it back. And you'll see I went back to 1632. But now if I go into my level of detail here, and you can simply double click to activate it, notice it goes back to 522, right? So we have some, a lightweight model in here. And now remember here, when you open it up as well, you can always open it up from a specific level of detail. So here I'm going to switch over to one of my lightweight views as well. So again, it brings back my enclosure. And what I've done is I've created this as a single part instead of an assembly. And I want to show you some other components that you have to kind of simplify your model. Now, again, why would you want to simplify your model? Again, with an Inventor, we're going to get all the detail that we need. Simplifying the models, they're less detailed and they're easier to consume within other, programs. So if I wanted to go to Plant 3D, or if I wanted to go to Revit and so forth, right? I want to make sure that my data is nice and lightweight to send out to those other programs, right? So again, Inventor users can easily transform their manufacturing models into a simpler representation. For a manufacturer, yeah, I need to show all the detail. I need to show all the connections, all the nuts, the bolts, the fasteners. But inside of Plant 3D or inside of Revit, I might not need to show that information. So what we can do is we can simplify it further. So let's take a look at how we can do that. So in this model here, I have some options in here that I can do a shrink wrap, or I can create a shrink wrap, a substitute level of detail. If I go into the level of detail, I can go into new and click on shrink wrap, and this will allow me to shrink wrap the model. But before we do that, let's go ahead and create a simplified view here. So on the Assemble tab, underneath the simplification, if you click on the pull down, this is where you can start to define those views. So I'm going to go ahead and click on Simplified View, and it's going to bring up a dialog box that's going to allow me to kind of control and view, what components do I want to include and so forth. So right now, this is showing me that everything that I have within my view here. So I want to include this enclosure. I want to include these pipes. And let's just say I want to include these silos here as well. Now, if you had this option turned off, which is the select all occurrences, you'd have to select them one at a time, right? So, just watch out and make sure that you have that turned on. So here, if I go ahead and click OK, what it's going to do is it's going to create a level of detail in a view for me that I can use. So notice here, I've got a simple view here. Again, my occurrences and so forth haven't changed. It's just gone in and created a view for me and turned off the visibility of all the other components. Let's take it one step further here. If I wanted to edit the view, I can simply right-click on the view and click on Edit View, and this will bring back and allow me to include and exclude certain components. So here I'm just going to cancel out that. I'm going to keep it how I have it. The next step is I want to define envelopes. So what this does is it's going to allow me to create bounding boxes, right? I don't need all this detail, for this enclosure. So let's go and select it. And once it's selected, I'm going to go ahead and change it to, instead of a cylinder, it's going to pick it up as a rectangle. So let's wait and so with this, it's going to allow us to create bounding boxes within the assembly here. So here I'm going to say I want a bounding box to show that, and I can go ahead and click on Apply, and I'll show you what that's going to look like. So notice here it gets rid of all the detail here. And again, the same thing that I want to do to the cylinders up here. So again, if I select the cylinder and I want to make sure that it's not a box, but I want to do this as a cylinder here. And again, I'll go ahead and click on Apply, and it applies it to all the views here. Now again, I brought in the extra fins over here as well. So here I can right click on it and do Edit View. And I can go back and say that I want to exclude. So here, if I go into View What's Excluded, and then here I can select whichever components that I want, and then I can go back and see what's included, and I can exclude those, and then click on the check mark, and it just updates my view here. Now for those envelopes here, I can go ahead and edit the envelope, change the bounding box the way that I want and so forth. So again, this is a way that you can simplify the model further. Now with the shrink wrap command, if you go ahead and select that, this brings up our shrink wrap dialog box. Again, you can specify the level of detail. You can include and exclude certain components. And then this is the great benefit here is, removing features. Let's just say you had internal IP that you wanted to remove and so forth. We can remove holes, we can remove pockets, we can remove fillets, and we can remove chamfers and so forth, okay? So that's what the shrink wrap's gonna do for us. So I'm gonna move over to another assembly, which is inside of our chiller assembly. And let's just say this is the model that I'm gonna send out to Junaid for him to use. So he's gonna be referencing this pump here, but I want to clean this model up, right? Because he doesn't need all this detail. So again, if I go into creating a shrink wrap, here I can say, what do I want to exclude? I want to go in there and I want to exclude all these nuts and bolts and washers and so forth. So here I can simply click on it and it's excluded out of my assembly. Here, if I click on that top, cover, maybe I want to see, the internal components in here, right? Again, when we get into the features, we've got the pockets that we can remove, the internal IP that I might have, let's get rid of that. So our options in here, we can say that we want to remove all of them, or we can say that anything smaller than a certain size, we want to remove and just fill in. So what it's going to do is it's going to fill in that solid, and we won't be able to see all those holes and so forth. On the create side, you have some options in here that we can break the link back to the top level assembly. Again, we can fill in all the internal voids and so forth. So again, when you're doing the shrink wrap, you have to be careful, because if you do have a large assembly and you're doing the shrink wrap and you try to do all these internal voids, removes, and so forth, it might take a while for Inventor to kind of clean up that model. So I've already gone in and kind of created my own substitute level of detail here. So I'll go ahead and click on that, and notice I've gone in and just cleaned up, all of my references in here. So this is a substitute level of detail within the assembly, but notice here, I can create a shrink wrap part as well. So again, taking that pump and, having it on its own skid, now we can bring it down and narrow it down to have it just on one part here. Going back into the assembly, that's my shrink wrap level of detail and so forth, right? So here, if I go into my master view, here you can see that's going to go in and turn on, all the nuts and the bolts and the fasteners. If I go into my substitute level of detail, simply double clicking on it, notice it narrows down my assembly and it just brings in one part. Now, how do we get this into Plant 3D? How do we get it ready for it? So underneath the Environments tab, you've got BIM content. So inside of BIM content, what you want to do is, notice here you've got, cable tray connectors, conduit connectors, the ducts, and the pipe connectors. So here, if I go into the pipe, again, Junaid's going to be working with these flanges here. I can go ahead and select on an edge, and I can pick whatever system type I want. So here, if I go into other, I can put in, it's a bidirectional, what's the connection type in here. So again, this one's going to be a flange, and then I can specify the diameter that I want to use, right? So where this gets built in, notice here underneath my MEP system connections, underneath the pipe, I've got two connectors that I've already set up. Now, because this is a light model, what I can do is I can export the building components here, and I'll show you that you have some options in here. So if you're going to export this to Revit, you have an RFA model that you can create, or for Plant 3D, we've got the ADSK model here. So what I'm going to do is I'm going to transfer it back over to Junaid, and he'll be able to open up this exact same model here that I've already exported to an ADSK file, and he'll be able to work on it within Plant.
Thank you, Imran. Give me a moment to share my screen. Okay. So I'm going to go to my equipment drawing now, and I'm going to import the ADSK file that I received from Imran. So that's my equipment drawing. And here in the equipment panel, I have a button to import the inventory equipment. So I'm going to click on that button. And the ADSK file is sitting on my desktop. So I'm going to select that. And program is now asking me to choose the insertion point because I have to place that somewhere in my drawing. So I'm going to type the coordinates in my command line. Define a rotation to the pump, and then program is going to ask me to select the class of this equipment, and based on the class that I select, the Plant 3D software is going to assign the correct class properties, the correct tagging format, and the correct annotation style. So I'll say this is the pump, click select, and it has now been converted into a Plant 3D equipment. If I double click on this pump to open up the properties window, you can see that all the class properties which are available to the pumps in the Plant 3D are now available to this pump as well. And if I want, I can start filling in all the information, just like you normally do for all the equipment in Plant 3D, either by typing the information in the properties window or in the data manager, or by exporting to the Excel sheets. I also can right click on this pump and assign the tag. So I'm going to type a tag, and when I highlight this pump by clicking on it, you can see that the Plant 3D automatically recognizes these two nozzles. So I can go to the Edit Nozzle dialog box, and here you can see that the nozzle sizes are displayed correctly because these are the nozzle sizes that were assigned to these nozzles in the equipment in Inventor. So if you want, you can make some adjustment to the nozzle properties. So I'm just gonna change the pressure class. And when I hover the cursor on these nozzles, you can see that the program now shows me the updated properties for these nozzles. Okay. In the end, before I go back to my piping drawing and start drawing my pipes, I'm going to make a copy of this equipment. So I'm going to use the AutoCAD copy command, and could be a good idea to have the ortho mode on. and let's make a copy of this pump. When I hover the cursor on the copied pump, the program shows me a question mark with the tag, which is an indication that the tag needs to be changed. So I'm going to change the tag for this pump, and the tag is changed here, and the tag has been properly assigned to the other pump as well. I'm going to save my equipment drawing, go back to my piping drawing, which is where the equipment is attached as an extra, and I get a notification that my reference file has been changed. So I'm going to reload the equipment drawing, and the pumps coming from Inventor are now displayed here in my model. Next I can select the size as 4 inches, because the top nozzle is actually 4 inches. So I'm going to select the size, and I'm going to go to the tool palettes, and I'm going to select a check valve and place this check valve right here on this nozzle. Okay. I can snap to the node of the nozzle, and I can do the same with this pump as well. Make sure it snaps to the node of the nozzle. Next, I can click on the check valve, use the plus sign grip to continue the pipe routing, right click, pipe fitting, and I'm thinking to select a double disc flanged gate valve, and I can do a fitting to fitting connection. Define the orientation or rotation for the hand wheel, give the pipe a value of length, and I can use the auto routing to snap to the nozzle on this exchanger, accept the placement, and I'll do similar steps quickly on the other check valve as well. Plus sign grip, right click, pipe fitting. I'm going to select the double disc flanged gate valve, and I'm going to do a fitting to fitting connection. Define the rotation for the hand wheel, and I'm going to connect this pipe to the pipe above. This is it. I also can make some adjustment to the pipe elevation by using the AutoCAD dynamic input feature. I'm going to make some adjustment to the pipe elevation with reference to the bottom of pipe. And in the end, I'm going to end the component placement by placing a pipe support. So I'm going to go to the pipe support spec and place this support here on the pipe. I can make some adjustment to the placement of the support by using the grips. And using the grips, I also can make some adjustment to the geometry of the support. In the end, I'm going to highlight all the pipe run, and I'm going to assign a value of line number to this pipe run. So say that the line number is 2000. Line number is assigned. Save the drawing, and let's go inside the ISOs tab to generate an ISO drawing. Generate the ISO drawing of the line number 2000. Select one of the ISO styles available and click on the create button, and program will give me a notification in the command line that the ISO creation is processing in the background. While the program is processing the ISO in the background, you're free to zoom in, zoom out, and carry on working on your model. And the program is going to take some time depending on the amount of information the program is trying to process in the background. So in only a few seconds, the ISO should be processed and generated. And once that's processed, I'll open up the ISO drawing, and you can see that the ISO drawing will properly show you all the bill of material tables and everything. Here's the notification I get, and this is the ISO drawing. I open up this ISO drawing, and this is the typical ISO drawing. It shows me the bill of material table, and it also shows me here that the lines are actually connected to P-100B and P-100A, which is actually the tag numbers that I assigned to the pump coming from Inventor. Okay. The ISO output can be customized according to your project needs. Next, I also can create the orthographic drawing so that we can see how this equipment shows up in the ISO drawing, in the ortho drawing. So I'm going to give it a name. The ortho drawing is generated, and my whole model will be shown up in this ortho cube. Okay. To make sure that the equipment and structure is also shown up, I'll click on the 3D model selection button, and I will make sure my equipment drawing is selected and my structure drawing is also selected. I'm going to click OK, and the program refreshes the whole model to show me everything. And I can use the navigation cube to make some adjustment to the length, width, and depth of the cube so that everything shows up properly inside the orthographic viewports. I'm going to change the view to top view, and I'm going to make some adjustment to the ortho cube, which is simply moving around unless you have a satisfactory view. So I'll say that I want to create the 2D projection from the top, and you can make some adjustment to the hidden line piping, match lines, cut pipe symbol settings. Okay, and I want to create the 2D projection from the back, and I will assign the scaling, and I'll click on the paper check. And I also can go to the back view using the navigation cube, and you can see that how big or how small your orthographic viewport is going to look like on the orthographic drawing. So you can always make some adjustment to the scaling. I click OK, and program is asking me to place that viewport on the orthographic drawing. It's going to query the drawing, collect all the geometry, and show you the 2D projection from the back. This is the equipment which is coming from Inventor, so I'm going to use one of the available annotation style to annotate this pump in my orthographic drawing. And if I need, I can also modify or customize these annotation styles according to my project needs and requirements. I also can create the report using the plant report creator tool. So I'm going to create a report for the 3D parts, for example. You can do a preview just so you can see if everything looks good. If you're satisfied and everything looks good, you can generate the report by using in one of your preferred file formats. So you can click on print export, and it actually creates the report in this Excel file format, and the output can also be modified according to your project needs and requirements. This brings me to the end of the webinar. We will be getting in touch through emails with all those who ask questions and try our best to provide you with the answers. Meanwhile, if you come across any further questions or concerns about the products, please do not hesitate to reach out. If you would like to have a discussion or if you need some further information about the products, we are only a phone call or an email away. Our contact detail is displayed on your screens in front of you. Once again, thank you for registering and attending, and we look forward to hearing from you. Goodbye.